Hi, welcome to the Neurorevision Lab. Today we're going to take a look at collision theory from the topic rate and extent of chemical reactions. The things you'll need to know first are the particle model and basic reactions. By the end of this video, you'll be able to explain using collision theory why reactions occur, and you'll be able to list the 4 conditions that increase the rate of reaction. Your keywords today are activation energy, rate of reaction, successful collision, collision frequency, and random. Take some time to write these words down in your revision books. You can practice spelling and sounding them out. Listen carefully to how these words are used, and you can research their definitions later. Collision theory is the underlying idea of particles colliding together and reacting. It's important to remember the definition for collision theory as it is fundamental to chemistry. Understanding this means it's much easier to be able to understand other things later. First up, particles move randomly in gases and liquids. This means they will often collide with each other. When 2 different particles, either elements or compounds, meet, they must meet 2 criteria. They must collide with enough energy. You may recognize this as activation energy from exothermic and endothermic reactions. They also need to collide at the correct angle to make or break those bonds. If they fail to meet those criteria, they simply bounce off of each other in an unsuccessful collision. But if they do, they will successfully react and form a new compound. In summary, collision theory is the idea that particles move randomly, and in order to react, they must collide with enough energy and at the correct angle. Obviously, we can't sit around all day waiting for some reactions to happen, so we can help them along to react a little bit faster. The first thing we could do is increase the temperature. This gives particles a higher energy level and more frequent collisions as they become more excited. We can also increase the pressure. By pushing the particles closer together, we get more frequent collisions, so more chance of a successful collision. We can also increase the surface area. In a block of solid, only the outside surface can react, but if we break it down into a powder, each individual grain is now exposed, dramatically increasing the surface area. This means more reactant particles are exposed and more successful collisions can occur. And finally, we can increase the concentration. The more reactant particles we have together, the more frequent collisions will occur. It can be quite helpful to think of models when learning collision theory. My favourite is microwavable popcorn. Increasing the temperature, pressure, surface area, or concentration all results in faster popping and a lot more popcorn. At this point, your revision should look something like this. Feel free to pause the video and update your notes. They should be clear, purposeful, and you should feel proud of the work that you're doing. Alright, so let's crack on with the exam question. I have 2 extended questions for you this time, worded slightly differently. Don't forget to read your question carefully, and if it helps, you can highlight the command words and keywords. There are no numerical values in this one. Question A. Explain why increasing the temperature increases the rate of a chemical reaction. Question B. A student investigates how the surface area of a solid affects the rate of reaction. They react magnesium ribbon and magnesium powder separately with dilute hydrochloric acid and measure how quickly the gas is produced. Explain, in terms of collision theory, why the magnesium powder reacts faster than the magnesium ribbon. A helpful tip for you: For extended questions like both of these, look at how many marks there are. That tells you how many bullet points you need, and bullet points help us to stay efficient and avoid waffling off topic. We'll take a look at the answers in just a moment. For more revision resources, tips, and helpful materials, please visit the Neuro Revision Lab store. Everything there is specifically selected or made for neurodivergent learners, and each purchase supports the channel and helps keep us producing video content. As usual, subscribe, like, and share this channel. Okay, so let's look at these answers. I hope you didn't let the short question fool you. It was actually asking for 4 very specific key phrases, and hopefully you've probably guessed them. It's our definition of collision theory. Increasing the temperature gives particles more energy, so they move faster and collide more frequently with enough energy to react. Easy. Question B. This question's a little bit more extensive, but hopefully you spotted that the real question is in the third sentence. Explain in terms of collision theory why the magnesium powder reacts faster than the ribbon. You should have something like magnesium powder has a larger surface area than the ribbon. More particles are exposed to collisions with acid particles. This causes more frequent collisions per second. Therefore, more successful collisions occur, increasing the rate of reaction. Anything along those lines, and usually there's a few options for examiners to choose from, and you'll get those 4 marks. Well done, you made it to the end of collision theory. Next, we'll take a closer look at the different practicals that demonstrate factors such as concentration and heat, which can speed up reactions. If this video helped you in any way, make sure you like and subscribe. You'll probably also love our specialist neurodivergent notebooks, designed to make learning clearer and easier. They're partitioned and an excellent addition to EHCPs using the Cornell note-taking style. See you next time on the Neuro Revision Lab.